Today, we are going to see very important concepts in statistics, especially in the world of inferential statistics, where we are trying to draw inferences and also test the hypothesis. So, this is the foundation concepts. So, let us see what is a central limit theorem. As the name suggests, a central, something is at the center. And before understanding the central limit theorem, we first need to understand two important concepts like what is population and what is sample. By the name, it is obvious that population would be the entire universe. So, say suppose this is the universe, and sample would mean few observations from the population. For example, if I have to find out what is the average weight of all the people in the universe, then it would be impossible to measure every single person and find out the average weight. So, what we do instead is we have the samples. We take samples from different parts of the universe, and now we can draw some inferences based on these samples. And how we derive the inferences is given by central limit theorem. And that is what we are going to see, that what is a central limit theorem. There are basically three important tenets of central limit theorem. The first principle says that for each of these samples, so so for example, say suppose we have 10 samples, 1, 2, 3, 4, likewise we have 10 samples, and in each sample we have a number of observations. So for every sample we are plotting the mean. So observation for sample 1, the mean is 15. For sample 2, the mean is 20. For sample 3, the mean is 10. Similarly, so we have 10 samples, so we will get 10 means. Sample 1, mean sample 2, mean sample 3, mean. We will get individual samples. So the first principle says that when we plot the means of each of these samples, then we will get a bell curve. It says that we will get a bell curve. When we get a bell curve, then it becomes easier for us. Then we know that what percentage of population will lie between plus minus 1 standard deviation, plus minus 2 standard deviations, plus minus 3 standard deviations. So the first principle becomes very useful for us. The second principle says that if I take all the sample means and do a summation of all these sample means, so if I do x1 plus x2 plus x3 plus xn, and then I divide it by 10. So what I am doing here is I am taking all the individual sample means and then trying to get an average of that. So this means of the sample means will be equal to population mean. So this becomes very crucial, right? It makes our life very simple, because now I don't need to measure every single person in this universe. I can take the samples, take the means of these samples, and then I can take the mean of all those samples, and then I can say that, okay, that is the population mean. So my life is easier now. But wait, let us look at the third and most important principle. It tells that given the standard deviation of the population, the standard deviation of the sample means, which is also known as the standard error, is given by standard deviation of the population divided by square root of number of observations. So that is there. This is important to understand here, that we want the standard deviation of the sample to be equal to standard deviation of the population, and for this has to be low as possible. The denominator has to be low as possible, and hence we prefer a large sample size. Large samples size. So these are the three main important concepts that we need to understand, which is given by Central Limit Theorem. Now let us look at z-score. When do we use a z-score? Now what is a z-score? So we know that this is the bell curve, this is the mean. Z-score tells us how many standard deviations away is my own data point. So I have one observation and I want to understand that how far this observation is from the average of the population, and we don't want it in absolute units, we want it in standard deviation units. How many standard deviation units the observation of my interest is far from the sample mean. So what are the uses of z-score? There are two most important uses of z-score, that is standardization. We would need to standardize the data. In a data set, say suppose one column is of age and one column is for income. Age would be like 1, 2, 3, 4. Income would be 10k, 20k, 50k. In future, when we do machine learning to solve some cases, then and if we are using a distance based algorithm, then 1 unit change in age is not equal to 1 unit change in income, right? We have to prepare the data for machine learning. Here we can prepare the data using z-score, we can standardize the data using z-score. There are other ways also to standardize the data like min, max, scalar, etc. But right now just be aware that this is one of the uses of z-score. One of the other uses of z-score is comparing two groups. For example, India and US. If I want to compare these two groups, then I know that this group is very different from this group. For example, in India, the number of employees is 5,000 and in US the number of employees is 1,000. I have done a satisfaction survey, engagement survey, and I found that the score here is 3.5 and here the score is 3.2. So can I say that in India the engagement is higher, the employees are more engaged as compared to US? Can I say that? No, I cannot say just looking at the average scores of two groups. These two groups are different. Here I need to form the null hypothesis, form the alternate hypothesis and run a score, find the z-score, see the p-value and then accordingly accept or reject the hypothesis. So when we are comparing two groups, then we can use the z-score. Now let us look at coefficient of a variation. So all these concepts that we are trying to understand is where we are trying to find the difference between the two groups, and whether the difference between the two groups is statistically significant or not. Can we say with confidence that these two groups are different? For example, can we say the engagement is higher in US as compared to India? Can we say attrition in US is higher than in India? Can we say, so these examples, right? When we are comparing two groups, we need to do some hypothesis testing, and we need to move beyond just aggregate percentages to say with validity that yes, the difference in the means of these two groups are statistically significant, and there is a need of intervention by the management or the business leader. So coefficient of variation is one way to see the variation between the groups. For example, salaries in US, if the coefficient of variation for salaries within US is 1.5 and salaries in India is 1.2, then that tells us that in US there is higher variation within the salaries that are being, there is a high range of salaries that are being given to the employees in the US. So is this good or bad? A higher coefficient of variation in US for salary, is it good or bad? It is bad, because there is a wider distribution. We want a tighter distribution, a central distribution. So this is one of the ways in which we can understand the two groups, how they are different, and take some informed decision. Now next we will see what are the different kinds of inferential tests are there, what is the basic concept of hypothesis testing, what are the different tests, statistical tests that we can do in terms of z-score, t-test, chi-square test, f-test, ANOVA test, which test to use when. Most importantly, we will understand p-value, what is level of significance, what is confidence level. So I'll see you in my next video.